We're talking about transformations of quadratic functions in standard form. We want to graph quadratic functions and determine whether it has a minimum value or maximum value. The first thing I want to do always is identify the a, b, and c value. So a is always the lead coefficient, which a in this case is 1/2. B is always the linear term, or the coefficient in front of the x, which in this case is 2. And c is the constant term, which is all by itself. C is also the y-intercept, and that has the ordered pair of 0 for the x, and then whatever the c value is. So in this case, it's 6. So when we go ahead and graph this on the y-axis, we want to count by 2, so we'll go 10 and -10. And on the x-axis, we can count by 1, so we can say -5 and 5. Next thing I want to do is calculate the line of symmetry. And the equation for the line of symmetry is x equals -b over 2a. So we can substitute the values in. So the only thing that's going to change is the b value and the a value. So the b value is 2, and the a value is 1/2. 2 times 1/2 is 1. So x is equal to 1. Negative times 2 is -2. So the equation is x equals -2. So on the graph, I'm going to draw a vertical line at x equals -2. And this is going to be the line of symmetry. So this is going to split the graph in half. So you're right, x equals -2. Now, we've already calculated the line, or we found the line of symmetry is 0, 6. So 0 and then up to 6. 2, 4, 6. So that's 0, 6. And because we know the line of symmetry is right here at -2, if I count over 1, 2, 1, 2, I know that there's going to be another point right there because parabolas are symmetric over the line of symmetry. The last thing I have to do is I have to identify if I'm going to have a minimum or maximum and then calculate the vertex. In this case, the a value is 1/2. So that's positive. So I know that my parabola is going to open up like this. So there's no top. These arrows go on forever. There's no top. So that only means that there's a bottom or there's a minimum value. So I am going to have a minimum value, and that's going to be the vertex. And the way that we find the vertex is we take our line of symmetry, which we've calculated, and we substitute it back into the original equation. So the original equation is the function k evaluated at x is equal to 1/2 x squared plus 2x plus 6. And so we're going to take that function, we're going to substitute in the value of -2. So I'll take the function k, we're going to evaluate it at -2, 1/2 squared plus 2, need a little more room, plus 6. And we can substitute in the -2. And we'll just work our math from here. So the 1/2 comes down, -2 squared, that's -2. -2 squared is the same as saying -2 times -2. And that is equal to +4. So we'll put a +4 in there. Plus 2 times -2 is -4, and then plus 6. 1/2 times 4, 4 divided by 2, that is 2 minus 4 plus 6. And we can finish up by saying the function k evaluated at -2 is equal to 2 minus 4 is -2 plus 6 is +4. So we have the ordered pair, -2, 4. That is the vertex. And so we can go and graph that point of -2, 4. So -2, 4. Yep, -2, 4 is right there. And then we can sketch the parabola that goes through that.